Hey guys, it's Vince. Today in this video, we are up to volume number 21. Yes, lucky number 21 in the CNC Controllers Built Incorrectly series. Last week, I did a video that was more of a compilation, and I feel that you guys are getting more out of those videos. The compilations are cool because you get to see the different genres of CNC robotics, and again, a lot of the same material that's being spread as far as misinformation is what we can see from the different genres, and yet it all ties into one and the same. So let's jump right in and get it going.
All right, so we're working on electrical. Most of this I've already started.
Okay, so there's always a couple people since I've started this series that will say, well, none of these content creators claim to be experts on working with CNC electronics, and that is totally true. But you know what else they don't claim? Not to be. They don't explain at all, as far as a disclosure in the beginning of their videos, hey, I'm building this unit for myself, and you should not be following what I'm doing because I don't know if I'm correct. You will never see that because that would make most of their audience lose interest immediately in their videos. That being said, let's see where this goes.
I'm using for my electrical box this Calypso, I'm guessing that's how you pronounce it, off of Amazon. It is a 11.
Okay, here is one of two critical mistakes I see end users make when selecting their electronics enclosure. Number one, they either select electronics enclosure that is too small. Why do they usually select the electronics enclosure that's too small? Because they don't have the correct budget to actually buy the correct size unit. That's the first area of concern where they say, hey, you know what? I only have this much money. I'm going to go as small as I possibly can. If they buy too small of an enclosure, what they typically find with an IDS system, which stands for an individual drive system, is you're going to have a lack of proper cooling capacity for all of your components. That means your power supplies, and that means your drives for the selected many of axis you're running. Now, keeping that in mind, the next mistake that we typically see is end users will select an enclosure that is not conductive, meaning a plastic enclosure. If the plastic enclosure is selected and the enclosure itself does not have a base plate that's conductive, meaning made out of metal, you are going to find you cannot ground the enclosure. This is a very critical mistake. I see it done all the time. Another reason they pick a plastic enclosure is they think it's easier to machine. Now, it usually is easier to machine, but this is where understanding and having the knowledge of what you're building is really going to determine what electronics enclosure you pick. That's why if you guys review my store and you look at my pro-grade CNC electronics enclosure, which I specifically designed for IDS system, individual drive systems, they are EMI shielded, meaning they're dipped in an EMI coating, on top of them being the correct width at 19 inches wide by 24 inches long by 8 3/4 inches high. Now I go high enough to where I let end users select to either stack components if they need more room. At being 2 feet long, it allows them to then select how many components they want to install, where they want to install them, and then 19 inches wide, naturally you've got plenty of real estate within that unit to actually go in and mount everything you plan on doing, not just in the beginning when you're building your system, but also for modifications later. A lot of guys never think about what they're going to do when they want to change something in the system. It makes it much more tedious to work on. Looking at this enclosure, I can tell you right now it's a standard enclosure. It does not break down. My enclosure totally breaks down, meaning all the side panels and the front and back plate can be removed so they can easily be worked on. Plus, they already have the machining GX16 locations in the rear back plate for your IEC, your power switch in the front plate, and so on and so forth to make it much easier to assemble. When you factor all of those things in, you have to think about where you're going in the future with this enclosure. I've had end users tell me they want to purchase an enclosure whenever they update their system. To me, that makes no logical sense because all you're doing is spending more money, when if you just saved a little longer and bought the correct enclosure size, you'd be all set.
Then by 15 by 9, I believe, was the dimensions.
Once again, we have another Arduino USB board being used, and it never ceases to amaze me how many of these content creators copy other content creators to build systems with and film it. Many of you who are new here, go back in some of my CNC fail video series and you'll see the original guy who designed the system that this guy is working on, and all he's doing is copying this controller from his controller, and it's astounding to me that they continually spread this misinformation, and it's a literal domino effect to who is seeing this. And I'm hoping YouTube catches on at one point, or at least other end users are bringing it to their attention in their audience, because it is really unreal how many of these content creators fail to do any significant research. And what's really funny is there is more and more postings of these Arduinos being unstable when used with CNC robotics. I'm seeing it all the time. I hear about it all the time. So I'm going to post again the email that was actually written to me from Balzis, lead engineer at CNC Drive in Hungary. They're the leading manufacturer in the USB motion controller known as the UC100. And you guys can see what he explains: the voltage problems, the grounding problems, the Windows power management issues. These devices are simply not stable for USB control. And why we see so many content creators using them, of course, is once again that almighty dollar. It's cheap, and they think they're hacking the system by saving a bunch of money and using these controllers, and all they're doing is really shooting themselves in the foot, because to have a system stable with USB, especially for a plasma controller, it's virtually non-existent. I mean, it's hit and miss at best. And the big thing with CNC, as you guys get more and more involved with the genre, you're going to find out that you're going to want a system that you can count on. And I say that time and time again. Many of these content creators play a video for 3 to 5 minutes moving the machine, or it's doing a real quick cut just to show you what it can do. You'll never see them do a 10 or 11 hour production shift, because most of the time their machine is not stable. And of course, the longer they show video of their machine cutting, the more potential for it to be unstable. Do they ever know if it's stable? No, they don't. Nor will you unless you follow best practice. That's the more confusing area of CNC. Just because your machine is stable for the first 1 or 2 minutes doesn't mean the machine is stable. Stability is dictated over time. So therefore, unless you follow all of the best practices to mitigate EMI at a level that is so low it does not interfere with signals that the machine is sending and receiving, you essentially are a time bomb, and you never know when it's going to go off. Pay close attention to these guys and be careful.
Here is the electronics. As you can see, I started getting some of it wired. What's nice about that electrical box is it comes with this back plate. So you can see here all my...
So like clockwork, we can see that the back plate to his electronics enclosure is nylon. Yes, it appears that it's very easy to mount everything as it's removable, but once again, as discussed, it's non-conductive, so he will use a ground bus or a metal plate. If he uses a ground bus, he can just terminalize everything right off the ground bus. If he uses a metal plate, everything would screw to the metal plate naturally, and then it would be grounded. Pending, he would use a terminal splitter, which is metal, that has a ground lead coming from his power supply's ground run to it, therefore conductively grounding the back plate.
Here's what I was talking about. Nice straight shot over to that fan. This is vented on the back side, so it'll be vented there.
Okay, so we just heard him explain about the cooling fan that's mounted within his power supply's enclosure is basically going to vent all of his electronics enclosure where his CNC electronics are mounted from those little holes he has drilled in it. Now, guys, I want you to think about that, on how illogical that sounds. Anyone who's had familiarity with a DC power supply realize that these little fans that are mounted within the enclosure of it are just designed to circulate ambient air within that enclosure for the power supply's electronics. It's nowhere near adequate putting out the required CFM, cubic feet per minute, as far as output of the fan to cool his CNC electronics. This is why I say it's very dangerous who we take information from as a YouTube content creator. What's more important, and I want to draw your attention to something else, is I want you to pay close attention on any video you see online on YouTube dealing with this genre and see if their comments are directed towards these mistakes. Why I say that, we see a lot of agreement in comments. We see a lot of thumbs up, hey, you did a great job, so on and so forth. Are they really paying attention to what's being done? I mean, I really want you to think about that, because it's kind of frightening to think that in all of their audience, maybe some of these guys have, 10, 15, 100,000 subs. There's not one person out there that spots the knot, because this is completely obvious to anyone who's dealt in electronics in general, let alone someone dealing with a specialty source of electronics like for a CNC robot.
The torch. This is the switch that is on the Z-axis. When it touches down, it clicks that little switch.
Okay guys, so this content creator did select shielded cable. So he did have good intentions. Unfortunately, that's where it ended. He doesn't understand that he should be using double shielded cable, or he didn't want to invest in the proper budget to build this machine. Why must he use double shielded cable? Because double shielded cable mitigates both forms of EMI for CNC robotics. It's not just because I sell it. I sell it because I understand there are two forms of EMI that can actually jeopardize the stability of your robot. You first have a mylar foil, which is the single shield. The second shield is tin-braided copper, and they mitigate both high and low frequencies of EMI, which are present in a shop environment. Now, a misconception is that the robot itself is the only tool generating EMI. That's not true. If you have any other electrical devices in your shop, they're going to generate EMI as well. They may be generating a high or a low frequency, and your robot generating a high and low frequency, and when you combine everything, that's where the double shielded cable is most effective. Henceforth, that's why it costs more, but it's justified by knowing you have peace of mind by investing in the correct tools to build your robot. Once again, this is something that cannot be overlooked, and usually is by content creators because they can't justify the price. That's the first thing, and then it would fall into the lack of knowledge. Now, the other area of concern here is his solder joints. And I can tell you, like many of you out there working with electronics, you can look at joints and you can instantly see where we have blobbing occurring, which defines that he's not using flux. Now, I cannot tell you how many content creators formulating videos using soldering do not know how to solder. They are all over, guys. Many of them think that using a flux core solder means that they don't need to use flux when they're doing soldering. This is incorrect. Soldering flux is to be used on every joint. The flux within solder itself is just to help it adhere to the tip of the iron. It's not enough to do joints, and it should never be used by itself for joints, or you can have an inferior joint and it will fail. You can see here by looking at these joints, he did not apply flux. If he did, you would have had a capillary action from the flux. If you review any of my previous videos on soldering, you will see what happens. You'll get a beautiful chrome finish if it's a high quality flux, and it will flow. And with that flowing effect, we get penetration, and then we're going to get a much, much stronger weld, and that's exactly what we're looking for. And it's so interesting to me when I bring this up, how many guys will come back and say, hey, you're just being technical, you don't have to worry about that, this, that, and the other thing. But we use soldering when we actually weld pipes together for our house. I mean, if you think of copper pipes, plumbers use a soldering all the time. and they're called sweating pipes. Well, guess what? You wouldn't be able to sweat a pipe if you didn't use flux, and his joint would be inferior, no different than what we see with electronics. Yet guys are more accepting to this for some reason. I don't know what that logic is, especially when we can instantly cause a fire if one of these joints fail and you get arcing. So even low voltages can create arcing if a joint fails. Don't think that, oh, it needs to be, 120 volts or, 48 volts. No. 10, 12 volts, 5 volts. Believe me, wires can get very hot if they arc, and it can happen. I've seen it happen in the past, and I'm telling you guys, be very careful.
Is CNC capable for the torch, and it comes with the connectors here. So it's the pin 1 and 2 to the torch itself. And this is for part of the other wiring that we'll get into later, I think, for torch height controller and everything, which we're going to end up doing eventually. But yeah, so basically what we're going to end up doing is taking that shielded wire that I just built, 2-wire, and it'll come into this, which plugs right into the CNC machine, and then we'll just terminate the shield at this housing.
I'm sure many of you picked up what I did in that he has a GX16 3-pin connector mounted within his electrical enclosure. It's a panel mount connector. On the other end of that cable that plugs into that connector, he's putting a GX16 2-pin connector. Now, what logic that has, I have no idea. Typically, whenever you build a cable, everything is built in symmetry. What does that mean? That means that if you use a 3-pin panel mount connector in your enclosure where the cable will plug into, you would then use on the opposite end of that cable a GX16 3-pin. It's the same exact thing. It mimics both sides of the cable. When I see guys doing this, it typically means they're not thinking things fully through, number one, which means lack of experience, once again, henceforth lack of knowledge, or they're trying to use and create what's known as a hack because they just want to use what they have on hand, once again, because they don't want to spend the money to do it right. So I'm telling you guys right now, we don't do half measures, do things correctly. Don't solder a shield drain to a casing and think that that's okay to do instead of using the proper cable end. This is exactly what we see done by these content creators because, once again, it's easy to get content, and I'm just going to use what's on hand because it's much easier for me to do that rather than really think about what he's doing. Because if he's never soldered before, which we've already seen the joints that he's created, and he plans on soldering to a casing, that's going to be interesting to be done considering the fact he's not using flux. Think about what I just said.
So we can actually terminate it inside this metal. And then it's going to be grounded on the inside of the circuit board there. Okay, so for the end of this video, we had to order some stuff. It just came in. I decided to go with these type of connectors. You can get this entire kit. It was pretty inexpensive on Amazon. But this is going to be the connectors at the motors.
Okay, so as we previously discussed, we see him switch over to yet another connector that he's allocated for his motor use. Guys, a GX16 aviation connector, when soldered properly, provides the best connection for CNC robotics, mainly because it has a locking collar on it. It works like a nut. You would safely screw it into the panel mount or whatever butt connector you're using, and therefore it locks it together. What we're seeing here is done so many times by content creators because either they get tired of soldering or they think they're making their job easier by using more familiar connectors. Do yourself a favor. Stay with one symmetrical connector, as I've discussed before, and an aviation connector, once again, is the best used connector for safety. These type of connectors are not designed for robotics use, so please be careful.
So you've got the mill and ball screw kit to go with it. There's two more things you'll have to choose, the motor kit and the CNC controller.
Okay guys, let me give you a brief introduction on the video segment we're about to review. First and foremost, These are some of the most frustrating segments for me to review because these YouTube content creators base content around them as an end user of the equipment they've selected rather than them understanding the equipment they've selected. They want to portray to their audience that whatever they've selected as far as equipment is the elite. This is what you need to buy, yet they don't sell any of the equipment. They don't sell any of the controller components. They sell nothing. They basically just want you to feel at home with making your choices based on what they did. Now, where this video really goes awry is the fact that this content creator, like so many other, will try to portray themselves as an authority because of the way they're speaking. You'll listen to it in the tonality, you'll listen to it in the way they're directing the audience, and what's really interesting in the telltale signs, if we look here, we see either a limit or a home switch on one of his axes. Now, if we look at this, not only do we see a crimp connector here on both of the terminals for the switch, which I never recommend because crimp connectors are at best hit and miss based on the tooling being used and the end user doing it, but he's using a split lead going to this switch, which means he's not using the proper double shielded cable. So for such an authority, you would assume, like so many of these other content creators, he would be selecting the correct components to direct his audience. He's not. But what's interesting is he never ever covers any of the components as far as going in depth as far as the build of his CNC controller. And it's interesting because I had to go through this video very carefully up until he actually included a snapshot of his controller to see what it looks like. And you guys will figure it out as we get to it because, as I've said to you before, most of these content creators, what they do is speak solely based upon what they assume to understand, and very seldom are they correct. They are looking at getting involved in this genre, and within a month they think they know everything, and unfortunately, it's not the case. They seldom have the electronics background to understand the robot they're working with. They are just equipped at selecting a machine based on their budget, because that's what everybody does, and then they try to make it sound as if, oh, hey, I understand transmissions, and you need to use this kind of motor, and you're going to hear a lot of things in this that make no sense. Rest assured, I will clue you in on the details and set you straight on the facts, and then at least you'll make a more educated decision.
As far as motors go, there's 3 options and you should only really consider 2. The options are open loop stepper motors, closed loop stepper motors, and servo motors.
Did you guys catch it? He gave you guys 3 different motor options, and 2 of which are the same motor. A closed loop stepper motor and a servo motor are one and the same, in that both motors utilize an encoder to detect positioning and provide feedback for that positioning. Whether or not each one performs the same based on the motor's characteristics and specs selected, that is the only difference. They are identical. Once again, we already see the first red flag. Let's see where this goes.
I won't go into why here, but you should strike open loop steppers off the list.
Here's the second red flag. I won't go into why here, but you should strike open loop steppers off the list. Why? This makes absolutely no sense. You're not going to cover it in detail as much as you've covered everything else that you've selected for your particular machine. It's very interesting, guys. Think about this. When you hear any content creator say they're not going to go into detail about something, or for that matter, just avoid the topic altogether, it's exactly as I'm telling you guys. They lack true understanding of where they are. They think they know more about a topic than they do, and they're portraying, also known as posing, to be an authority.
So what should you get? Closed loop stepper motors or servo motors? The short answer is if you don't mind spending the money, definitely go with servo motors. They're quieter, more accurate, overall better, and also over double the price of the closed loop stepper alternatives.
Hey guys, I brought the snapshot just that was previously displayed back on screen for you guys to carefully review. I'll put the link in the video description. You can read this yourself. Oriental Motor is one of the premier motor manufacturers in the world of both stepper and servo motors. There is no benefit to them either way of what motor you select, and they plainly and openly discuss a stepper and a servo have the same accuracy. You can see it for yourself. And you know what? We all should know that, considering the accuracy of 3D printers, the accuracy of mills in general, where they started from and where they're going. We see a crossover now of a lot of guys thinking that servos are so much better, and they're really not. It's really just a question of your application. What do you need? If two guys want to cut a circle out and they want an accurate circle, either motor will do. And I've said this in previous videos, and for some reason guys overstep their idea of, once again, understanding, in that 99.9% of all production robots are never going to be your bottleneck as far as speed. I have not had a client yet tell me that a stepper robot is just too slow to keep up with production. It never happens. You know what happens? They say, hey, you know what? I'm taking in orders faster than I can keep. What can I do to make the process quicker? Well, the fastest way to produce more components is not one robot, but two. Another big misconception is that a larger robot means that you're producing faster. No, that's not true. Not unless that larger robot incorporates another cutting tool like multiple spindles. Then you'd be producing faster, or you can also incorporate a tool change mechanism, which once again would incorporate faster tool changes with an ATC spindle. Other than that, realistically, nothing beats two smaller robots versus one larger robot when production speed wants to be increased. And the benefit of that also, they take up less space and they usually cost a lot less. You usually can get 2 to 3 smaller robots for the cost of one large production robot, pending, of course, it fits your application. If you're doing cabinets, that changes things a little bit. But if you offset the fact that, yes, you're going to be spending more to get larger multiple robots, you're also making a lot more. So again, the ROI is always based on your investment and what products you're creating, and that's just part of being an entrepreneur and understanding your business model.
A closed loop stepper motor will move the mill in 1/1000th of an inch increments. And with servo motors, you can move in steps 10 times smaller than that.
Get ready, guys, because now I'm going to show you in a live demonstration sent to me by a previous client using my G540 system. After he's performed calibration, which he does on camera, he actually sent me a message through eBay. I recorded the message from eBay, showed you the videos that he sent me of him performing calibration and his direct reflection of what accuracy he achieved. And we're going to cover this in great detail. This is his machine performing calibration. The distance here is about 150 millimeters to 200 millimeters he's going through. You'll see this in another message. Now, I cannot emphasize enough, when we cover the resolution, this is where things really get impressive. I know many of you are thinking this is, like 1/1000th of an inch indicator. It is not. I'm going to let you watch some more of the videos. This way you can see exactly what he's working with. Here's from a different angle. You can hear how, you can hear how smooth his motors sound. I mean, the transmission on this machine is stock. He hasn't done anything. He's just doing fine-tuning and motor setup as far as motor tuning and dialing in the speed rates. you guys can see the repeatability on the indicator. It fluctuates very, very, very minimal. Okay. Once again, he fluctuated all the way from, we'll say, 2,000ths to 1,000ths. I'm not going to tell you the graduation yet. As we go through, I'm going to show you now actually engraving. Here we go. You can see he's got his mist cooler on, and he's engraving in aluminum. The tip on that is 0.1 millimeters, again, on the actual engraver. Okay, go to the next one. This one gives you really up close and personal look at exactly what he's doing. Once again, 0.1 millimeters, that tip is. You can see just how clean that goes right through. And again, with the mist cooling, he doesn't have it on real high, but you can definitely see it's doing its job. Definitively, this video really clarifies just how accurate these machines are when they're set properly. Once again, you hear the motors, how smooth they are. And we'll go back. And here is the finished template he made. You can see how clear that is. Now we're going to cover the resolution that that indicator reflected as far as accuracy, which I think is most impressive. I naturally asked him, the indicator is at Mitutoyo in the message. You guys can follow this through. I'm just going to skim across this. This is what his response was. Thanks for your prayers, Vin. So far everything is okay nearby, but we are really living a disaster movie-like situation. Unreal anyway. We'll win. Back to the machine. The indicator is 1,000th of a millimeter resolution, but a Chinese one bought off Amazon. For your information, the travel distance during measurement on the x-axis was 150 and 200 millimeters on the y. Absolutely no problem if you want to post the videos, because of course I always ask everybody if I'm able to use their videos. I will go ahead with fine-tuning in the next days and test at different speeds for a longer time to get motors well warmed up. I'll try and send more video with a first cutting or engraving test, and that's exactly what he did. Again, you can see this is my account. There's no joke here. So let's go over resolution. When that indicator was reflecting 0.002 millimeter, that's the equivalent of 0.078 thousandths. Okay guys, I'm on ChatGPT's website. I'm using 3.5 bot. Many of you may or may not know about ChatGPT. Some of you have heard about it online. It's basically an AI bot you can ask questions to, and it uses data provided by the internet through search engines to answer your questions. Now, of course, some of the questions may not be answered 100%, but if they're math-based, they're always 100% accurate because the formulas are online. So let's look at this carefully. What is 0.078 thousandths in inches? Okay, you can see what this translates to from thousandths to inches. This formula is accurate. And what I'm going to say, I'm just going to copy this. How would I say this in inches? That's right, guys. You can read what it just said. You could say that it's 78 millionths of an inch. And once again, you can see that in the video. This is not me doing the measurement. This is not me doing the calibration, not me providing him the tool. He's in another country. The message came through eBay. I mean, this is as unbiased as you're going to get using my own equipment. This is what's being provided now. Think logically. If this content creator is saying that a servo can move 10 times smaller than a thousandth of an inch, I would say a stepper is pretty much as accurate, right? I mean, I think many of you would be looking at this and just being shocked. I mean, let's look at this. What applications require this accuracy? I think that says pretty much everything. So for general accuracy as far as automation, and we're dealing with accuracy as far as machining, I don't know of one application that this wouldn't attribute to.
Transformer that powers all 3 motor drives instead of having one power supply for every single drive.
Okay guys, we finally come to the portion of the video where he displays his controller, and it tells me everything we need to know. If you guys are looking at this, you can see that we have shield drains coming from his motor cables that are not allocated anywhere to a ground bus. And again, that makes those cables basically inefficient and perform exactly as a standard cable. So after all the talk, all the direction, all the authority of buy this, buy that, pick this, pick that, what do you find? He didn't even build the controller correctly. And he could have found this information out had he done research, hit my channel, and used that information correctly. He would have been set. The issue we have here is, once again, it's more important to create content, regardless of how that content is, and they get motion. They think that now that they've got motion, they've succeeded, until they find out that I'm posting this online and now someone's actually looking to see if it's done correctly. And many of you have already seen all of the contradictions this person has made prior to this point. So I'm asking you guys, do your own research, and once again, pay very close attention. Content creators are just that, content creators. If this guy is doing this as a business, that's fine. But don't misconstrue someone discussing what they purchased as purchasing advice, because they're in no position to give that, especially considering the mistakes made when he's building his own unit. And just to be very clear, just because you purchase a CNC machine, aka robot, does not mean that machine is at all stable, because in the end, it all boils down to one area, and that is the CNC controller. If the CNC controller isn't stable, all of those investments you made with ATC spindles, spindle cables, laser cutters, water jets, you name it, it's all crap, because it'll be a paperweight. That's why I asked for what I asked for, because I'm solving a large problem.
Today we're going to go over...
Okay guys, just a brief introduction on this video clip, which I saved for last because I feel it's the best. This is a CNC plasma manufacturer, once again manufacturing plasma tables. They decided to make a video covering for their clients how to properly ground the plasma table. Now, many of you already seen my videos dealing with plasma table grounding. It's very elaborate, it is very complex, and it must be done correctly to assure a stable platform. This gentleman and his company feels they can explain this in a little over a minute video. I want you guys to see this because, again, many of you wouldn't believe this would be posted without me showing it.
Proper use of the star ground. So proper use of the star ground would be, this is the central grounding point for the table. You would essentially take a ground wire.
Okay guys, so we see the scale size of the table in reference to his body, and he's discussing using ground wire. You would never use ground wire on a chassis that size. Best practice, honestly, for all CNC plasma tables is to utilize ground strap. Ground strap is more conductive due to the fact it has larger amounts of mass, and it will dissipate all of the EMI much faster. Henceforth, that's why it was designed to lower resistance. Lowering resistance is extremely critical with CNC plasma robots. The faster we dissipate the electrical energy in the air, the more stable your robot is.
Not your work clamp. Your work clamp is actually positive. Everybody calls it a ground, but it's actually the positive. You connect this to here. You can essentially use a hand clamp, or it can be physically bolted. Some people physically bolt it onto the machine so that way the power unit cannot be removed. That's fine too. But this is essentially your work clamp. And
so I'm sure many of you, like myself, picked up that he started on one topic and went to another topic. We went from grounding to now he's dealing with his work clamp.
Is your positive. So when I say ground, going from here, what I mean is a separate grounding cable tying your plasma cutter to ground on the casework of the machine. That will help bleed off noise. So we want to go from here with a ground cable to a power unit, and from here to a ground rod. And that's very important. The ground rod cannot be a part of the building. You do not want this to be tied into your electrical circuits.
That is probably one of the most absurd things I've ever heard, and considering the fact we're looking at a direct excerpt from the PDF manual that was formulated by Lincoln Electric engineers on proper grounding, you guys can see for yourself how the ground rod is supposed to be implemented, and once again going to the ground bus within the electrical box as far as where your circuit breaker is. You can see this plain as day for yourself. I'm also going to put another snapshot on here of the diagram once again from Lincoln Electric showing how they ground their tables using a star point ground system.
It can cause noise interference with computers, noise interference with any electronic equipment, and just generally mess with other things that are in the shop. Also, you know, you just want to keep, essentially what you're trying to do is you're trying to take any noise, especially on a high amperage machine like a Max Pro, XPR, HPR, Kelberg 200, 400, you want to take that and dump it into ground and keep it off of the building and keep it off of the machine.
I, like many of you, have no idea what he means by keeping the noise off the building. If you guys use the ground rod as described by Lincoln Electric in the PDF user's manual of all their high dollar tables, which I'm sure are more valued than his table, you will find that they specifically state to have that ground rod connected, as I just showed you, to the ground bus within your electrical box. The whole idea is that that ground rod is going to dissipate all of the electrical energy to ground. And whether it's attached to the ground bus in the building and whether it's attached to Mother Earth, it's all the same. That's the whole principle of doing that. What he's talking about, where you're going to have EMI go into your circuits, I've never seen it. They've never seen it. It would certainly be in that manual, and that's why I'm telling you guys, be very careful. You could even hear in his explanation, he was a little stammered in what he was explaining. There is no way you can discuss grounding a CNC plasma system, especially one of that size, in a minute and a half. That should tell you guys something is off with this whole video. I can tell you right now, just by looking at the size of the ground bus he selected for that size table, something is off. We also only see 2 leads on this table, where proper grounding is a start point ground on all of the areas of the table. We're to dissipate as much electrical energy as possible. And the other thing we need to consider, which he's never even discussed, the table has a nice coating on it. Might be powder coating, could be paint. All of those coatings, once again, could actually insulate the table from making proper conduction to ground, which could also then mitigate you actually even being able to ground the table. It would all have to be removed. He never even discussed that. So again, these are things that are critical details they brush over when, again, either they're not having a full understanding of what they're working with. In this case, I don't know where this goes, because considering the fact he's manufacturing tables, and look at the size of that table, it's really scary, guys. This is not best practice. Read what we know works. Lincoln Electric has been around far longer than these people, and I can tell you right now, their engineers are paid properly. Their techniques are done properly. It will not be cheap to ground a CNC plasma table of that size or of their sizes. And that is why they go through doing everything in a systematic approach, and best practice must be followed to achieve the stability you're looking for with that type of production robot. And that wraps up volume number 21, guys. I hope you've enjoyed the compilation. I hope you've learned a lot. I hope, if anything, these videos just keep making you question what you're seeing these content creators put out. It's scary to think manufacturers are doing it. It's scary to think all kinds of information is being dispersed every day through YouTube. And realistically, as I've stated earlier, the only ones to hold people accountable for incorrect and inaccurate information is you. Be careful of what you're reading. Be careful of what you're viewing. Question it all and double check everything, and I guarantee you'll make the right investment. Thank you all for your support.